Now that we know how to make scatter plots, we're now ready to talk about some more sophisticated things dealing with those scatter plots and the patterns that we might see in them. So this is section 12.2. The I can statement is I can understand and identify linear correlation in scatter plots. So linear correlation, go ahead and write correlation there. And here's the warm-up. It says, does there appear to be a relationship between the x variable and the y variable? If yes, try to describe the pattern, for example, as x gets bigger, y gets either bigger or smaller. So let's take a look at this. Gosh, this one definitely has a pattern, so I'm going to circle the yes right here. And if you'll notice, as x gets bigger, so as we go further to the right, the y's get smaller and smaller and smaller. So for example, if we started off here with a small x, we have a relatively big y. And then as we get a bigger x, the y's get smaller and smaller and smaller. So we're going to say this, as x, and instead of saying gets, I'm just going to draw an arrow and say as x gets bigger, y gets smaller. That's just a quick way to do that, kind of indicating with the arrow what's happening with the growth. Then on this one right here, is there a pattern to this one? Well, gosh, this is just kind of a big blob right here. So I'm going to say no, there's not really a pattern there. But definitely on this one is a yes. So let's see if we can describe this. These are small x's and small y's, and these are pretty big x's and pretty big y's. So as x gets bigger, y also gets bigger. Okay, so we've got a couple scatter plots there. We can at least look at them. We know what a scatter plot is, and we can describe what's going on there. So take a look at this next stuff. I filled in almost everything on here, so let's read through this and fill it in. So it says there are many types of relationships or patterns that can occur between two numeric variables. Remember, we've got numbers that we're graphing on the xy plane. When there is a pattern between the variables, we say there's a correlation. So this is a new vocabulary word, correlation. The most common type of correlation is a linear correlation, and that's what we're going to deal with. And this type of correlation occurs when the scatter plot looks like a line. So if we do a scatter plot and it looks like a line, if there's some linear relationship to it, we call that a linear correlation. Now, it's important to please be aware of this. Most scatter plots do not look exactly like a line. In fact, they almost never look like a perfect line. We're just looking at the overall pattern. Does it look like a linear pattern? So in future classes, you're actually going to learn how to describe the strength of a linear relationship. So how strong that is, how tightly packed things are around a line. But for right now, we're only going to focus on one aspect of correlation, and that's just the direction. That's the only thing we're going to worry about for right now. So the direction of a linear correlation can be positive or negative. So when we say the direction of the linear correlation, we're just going to describe it as a positive linear correlation or a negative linear correlation. If the correlation is positive, the line that roughly fits the data goes up from left to right. And if the correlation is negative, again, we're just describing the direction, just the negative direction in this case, the line that roughly fits the data goes down from left to right. Well, if you stop and think about this, data that goes up from left to right is going to have a positive correlation, and data that goes down from left to right is going to have a negative correlation. Gosh, that sounds just like the slope of a line. So let's write the word slope right here. So it has a heck of a lot to do with the slope of the line that fits that data. So we're going to take a look here. Here are some examples. This is a positive correlation. The variables get bigger and smaller together. Now let me tell you what I mean by that. As x gets bigger, y gets bigger. So the bigger the x is, the bigger y is. And as x gets smaller, y gets smaller. So x and y do the same thing. They either get bigger or smaller together. For a negative correlation, as one variable gets bigger, the other variable gets smaller. So let me show you what I mean by that. As x gets bigger, so these are pretty big x's, these are fairly small y's over here. As x gets smaller, the y's get bigger. So x and y do the opposite of each other. They do the opposite of each other. Now, if there's no correlation, here's what that means. There's no pattern to what's going on in this scatter plot right here. In other words, the slope of the line that roughly fits the data. So unlike this one right here that kind of goes up, and this one right here that kind of goes down, this one kind of looks like that. So the best way we could describe a line would be something that goes through here. The slope of that line would be 0. Okay, so it'd be perfectly flat. So when we draw this little curve around there, instead of getting kind of a linear pattern like we do on these two, it's a big ball, okay, or it's a big flat, we're going to call it a blob. So if we've got a big flat blob or something like that, then we'd say the correlation would be 0. So now we've got a quick name for some of the patterns that we noticed yesterday, and the patterns in the warm-up. So let's take a look at how we do some of these. So classify the scatter plots as having positive, negative, or no correlation. Now I do want to point this out. I mentioned this just a second ago. One way we can help make a decision about the correlation is to draw a curve that encloses the whole data set as tightly as you can, and then draw a line roughly through the middle of that blob. Okay, in most data sets, doing this will help you see if there's a clear pattern or just one of those big blobs. In other words, no correlation. So let's do this. We're going to draw a curve around this guy right here. We're going to draw a curve that includes all of these points right here, a curve that includes all of these points right here, and a curve that includes all of those points right there. And then you're going to draw a line that roughly goes through the center of that curve that we just did. So I would say something about like that would go through the center there. This one's tough to tell. I mean, you could argue that we could go down, that we could go up. I'm going to draw one like this because, again, if we've got small numbers for x, we've got big and small numbers for y. If we've got big numbers for x, then we've got big and small numbers for y. This one right here looks pretty good, so I'm going to draw a line that roughly fits right there. This one's pretty well established. It goes like this. Okay, now if we're going to talk about whether there's positive, negative, or no correlation, this one goes up from left to right. So this one is a positive correlation. Okay, this one that goes down from left to right, that one is a negative correlation. Now on the two of these, we might have slightly different arguments here. Here I don't think anybody would argue that the slope of that line that goes through the center of that data would be 0. And what that means is there's 0 correlation, or we usually just say no correlation. No correlation on this one. Now on this last one right here, the second one that we observed here, that's a little bit different story. We look at this, and like I said before, we could make an argument that we could draw a line like this. It would be as good as any other. But if you get into a situation, if we've just got one of these big blobs like this, if you could make a bunch of different arguments for the way the line would slope, then it really doesn't matter. Okay, there's no line that would look good. So we would say there's no correlation on that one right there. Okay. So we've got our answers right there. We might occasionally run into something called an outlier. Now here's what an outlier is. You'll hear this in this class a little bit, but a lot more in future classes. An outlier is a piece of data that does not fit the general pattern. Established by the other data points. There aren't any outliers in the sets that we've seen so far. So my question for you is this: what would an outlier look like if there was one in example 1 above? So let's take a look at this, and I'm going to change colors right here. So anything that doesn't fit the pattern is well away from that established pattern. That would be called an outlier. Now, if there's no correlation, what that means is there's not really any pattern to this. So it'd be tough to have an outlier in those situations. But let me show you an example on A. If we had a data point that was like this, all of this other data kind of neatly packed around this little line right here, but this one's off by itself. That would be an unusual data point. That would be an outlier, because what we've got here is as x gets big, y gets big, and then we've got this other one down here that's got a relatively small x and a pretty large y. That doesn't fit the pattern. Same type of thing on C. We could put one down here. This would be a small x and a small y, but the pattern is generally as x gets smaller, y's get bigger, and as x gets bigger, y's get smaller. Okay, so that's what an outlier would look like. Let's take a look at the next page. On the next page, we've got an example that has a description. There is no scatter plot, so this takes a little bit of thought to figure out what goes on here. We actually have to think about the situation. So it says, would data from the situations below have positive, negative, or no correlation? So we just have to answer with one of these three: positive correlation, negative correlation, or no correlation. So we're just going to put positive, negative, or no. So it says the hours a person has been working and the amount that they are paid. So the hours they work and the amount that they get paid. Well, let's think about this, and I've got a little hint here. As the hours go up or down, what happens to the pay? Does it go up or down? So as hours goes up, what would happen to the pay? Would the pay go up or down? Well, if hours go up and pay goes up, that represents a positive correlation. By the same token, if the hours went down, the pay would go down. So they would do the same thing together. The age of a cell phone and its value. So as the age goes up, as it gets older and older and older, what happens to the value? So the older something gets, especially, with technology and stuff like that, then the value would go down. So that's going to be a negative relationship. That's going to be a negative correlation. The temperature outside and ice cream sales. So let's think about that. Temperature outside and ice cream sales. So as the temperature goes up, what would you expect to have happen with ice cream sales? So as it gets hotter and hotter and hotter, ice cream sales are probably going to go up. So that's a positive correlation there. The last 4 digits of your phone number and the score you had on your last math test. So the last 4 digits of your phone number, as that gets bigger and bigger and bigger, so as those digits go up, is that going to change or impact the score on your last math test? It's not going to do either one of these. It's not going to have any impact on it. That's going to be no correlation. Okay, the amount you exercise and the calorie you burn. Okay, I've gotten rid of the hints now. So the amount you exercise and the calories you burn. So I'm going to draw a little arrow here. The more you exercise, the more calories you burn. So they're both going to go up together. So if they were doing the same thing, then that is a positive correlation. Now this last one, there's something a little bit different about this one than the other examples on this one. It says your age and the color of your hair. Well, here's what's different about this. Your age is a numeric variable. That can go up or down. You might be really old or really young or whatever it is. The color of your hair, there's only a couple of choices. These are categories. Okay, brown hair, blonde hair, black hair, that sort of thing. These are not both numeric variables, so we can't really give a direction for this. So this is a pretty bad example. No correlation. So in other words, we're not going to be able to correlate a number and a categorical variable, a name of a variable, if you want to call it that. Okay, let's take a look at the next one. This says in example 3, Mr. Bentley was wondering if there was a relationship between the number of absences a student has and their grade percentage at the end of the quarter. In order to analyze this relationship, he created a scatterplot. So let's take a look at this scatterplot and see if we can figure out what's going on. You'll notice that the axes are labeled and scaled, so we definitely want to look at that. So the number of absences are over here on the horizontal axis. So 0 absences here all the way up to, looks like 28 absences here. Looks like somebody had 27 absences. And then on the vertical axis, it's quarter grade. So 0% for a quarter grade all the way up to 100% for a quarter grade. Doesn't look like anybody got 100%, but that doesn't happen very often. So here's what it says. It says, what does the circled data point represent in the context of this situation? So there's the circled data point right there. So this means we need to figure out what point this is. That point is 12, I'd say about 45. 12, 45. So that means the 12 is 12 absences. So 12 absences, and what grade percent did they get? 45% grade. Okay. Give a possible explanation for the cluster of points in the upper left-hand corner of the graph. Cluster of points up here. Okay. Now, if we say upper left, that would be kind of this one, or maybe we're going to circle those guys right there. Now, we're not looking for necessarily a correlation just among these, but we're looking for what this means in the context of the situation. So these people had maybe no more than 4 absences, and all of their grades are above 75%. So it looks like they've all got strong C's, B's, and maybe a couple of A's in there. So what that would mean is there are a lot of people who don't really miss a lot of school and they get good grades. So we're going to write this. Most people don't miss much school. Spell that right there. Okay. And get good grades. So most people don't miss very much school and they tend to get pretty good grades. It says, do there appear to be any outliers in the data? If yes, what are they? Now, if we were going to look at this and say, hey, what's going on here? If we were going to list a general pattern, if we had to circle everything, we'd have to go like that. But if we left this one out over here, we could circle these guys and say, gosh, that looks pretty well definite. That is a line that goes down. That would be a negative correlation there. This one doesn't fit the general pattern, so we're going to circle that one right there. So this would be somebody who missed 2 days of school and they got a 20%. So this one, 2 comma 20, 2 days and 20%. 2 days and 20%. So that's our outlier, and if we tried to explain that, that might be somebody who just struggles in school. Something that happens quite often, maybe they were sick the previous year. Maybe sick previous year. They broke their leg or something like that, and they missed a whole bunch of time. Okay, it says, does the scatter plot suggest a relationship between absences and grades? Describe any trends or patterns you observe in the data. Use the word correlation in your explanation. So there's definitely a pattern here. There's a kind of a downward trend like this. It looks like the more school you miss, the lower your grade is. So the more you miss, the lower your grade. So the more you miss, the lower your grade. So as the number of absences go up, your grade goes down. Well, that means they do opposite of each other. They're not doing the same thing like in a positive correlation. This would be a negative correlation. So this is a negative correlation. Negative correlation. Okay, that is basically how we do these. So good luck on the assignment. We're just kind of getting used to how scatter plots work and how we can talk about their direction as far as correlation goes. Is it a positive correlation, negative correlation, or no correlation at all? There you go.